Breaking news. At 02:58 UTC this morning, a routine mass estimation update triggered an automated anomaly alert inside NASA's Planetary Defense Coordination Office. Moments later, confirmation arrived from the European Space Network in Spain, followed by an emergency recalibration request sent to the Atacama Large Millimeter Array in Chile. An interstellar object that had been tracked continuously for weeks, an object whose mass had been carefully constrained through gravitational modeling, had suddenly changed. Today, the impossible just happened. 3I Atlas appears to have lost nearly 99% of its mass in less than 48 hours, without fragmentation debris, without an explosion, and without any detectable energy release consistent with natural disintegration. This changes everything we thought we knew. If you want real-time cosmic updates like this, events unfolding at the very edge of known physics, hit like, subscribe, and stay with us, because what we are witnessing now may not be an object at all. Before we examine what just occurred, we need to establish why the scientific community is treating this event with unprecedented seriousness. The data behind this conclusion does not come from a single instrument or a single agency. It comes from a synchronized global observation network spanning 3 continents and multiple wavelengths of light. Initial mass estimates were derived weeks ago using perturbation analysis on nearby dust, subtle gravitational effects on background objects, and Doppler tracking via radar and radio reflection. Those models were independently verified at NASA's Jet Propulsion Laboratory in California, at ESA facilities in Darmstadt, and by researchers at Harvard and Caltech running parallel simulations. The James Webb Space Telescope played a critical role, measuring infrared flux and thermal inertia to estimate bulk density. Hubble provided optical cross-section data, refining size estimates. ALMA contributed millimeter wave observations sensitive to cold material and diffuse debris. Together, these instruments painted a consistent picture. 3I Atlas was massive, far more massive than its visible size suggested, until yesterday. At observatories in Chile, Hawaii, and the Canary Islands, technicians rechecked calibration constants, fearing a systemic error, but the numbers held. The gravitational influence once associated with 3I Atlas was gone, not reduced slightly, gone almost entirely. To understand the magnitude of this anomaly, we have to rewind the timeline. 48 hours before the alert, 3I Atlas was behaving strangely, but still within the outer bounds of plausibility. Its velocity relative to the Sun was measured at 12.4 kilometers per second, already anomalously low for an interstellar object on a hyperbolic trajectory. Its distance was approximately 2.7 astronomical units between the orbits of Mars and Jupiter. Surface temperature readings averaged 312 Kelvin, warmer than expected, but not unprecedented given its unusual composition. Then came the first warning sign. 36 hours before the mass loss alert, spectroscopic data from JWST revealed a shift in absorption lines. Elements previously detected, carbon compounds, nickel traces, silicate signatures, were diminishing. Not dispersing into a visible coma, simply fading, as if the material itself was no longer there. At the time, researchers proposed sublimation. Perhaps an exotic volatile was rapidly evaporating, but sublimation produces gas. Gas produces pressure. Pressure produces jets, tails, motion. None of that was observed. 3I Atlas remained eerily stable, its trajectory unchanged to within milliarc seconds. 24 hours later, the discrepancy grew impossible to ignore. Gravitational models predicted that 3I Atlas should exert a measurable influence on nearby micrometer-scale dust clouds. That influence vanished. A recalculation showed the object's effective mass had dropped by over 90%. Within the margin of error, the remaining mass was equivalent to a dense metallic structure only tens of meters across. And yet, visually, the object still appeared roughly the same size. This is where known physics begins to unravel. In classical mechanics, mass and inertia are inseparable. You cannot remove mass without consequence. You cannot lose 99% of your mass and remain intact, stationary, and geometrically precise. No natural process could produce such symmetry, such control, such absence of waste energy. At 11:42 UTC, ALMA attempted to detect any diffuse debris field. There was none. No dust, no gas, no fragments. Space around 3I Atlas was clean. Inside mission control rooms, voices lowered. Conversations became careful. I remember watching the simulation replay on a large wall display, watching the mass curve drop almost vertically. One of the younger researchers whispered, "That's not erosion, that's unloading." At this point, a formal investigation was launched. Dr. Helena Strauss, a theoretical astrophysicist at Caltech, led one of the primary analysis teams. Her group ran over 10,000 simulations, testing every conceivable natural mechanism: tidal stripping, thermal ablation, electrostatic dispersal, even hypothetical dark matter interactions. None matched the data. If this were natural, she concluded, we would see chaos. Instead, we see precision. Another team at Harvard focused on energy accounting. Where did the mass go? Mass energy equivalence demands that if mass is converted, energy must appear. But detectors across the electromagnetic spectrum saw nothing. No gamma-ray burst, no neutrino spike, no heat plume. The mass was not destroyed. It was removed. As debates intensified, a second wave of anomalies arrived. Radio telescopes operating between 1.2 and 1.8 gigahertz detected a faint but repeating signal originating from the object's location. The pulses were weak, barely above background noise, but mathematically exact. Every 7.2 minutes, then 11.3, then 17.5. When plotted, the intervals formed a sequence of prime numbers. This was no longer random noise. Simultaneously, high-resolution imaging revealed that 3I Atlas had changed shape again. Its previously irregular surface had smoothed, edges sharpened. The object's albedo increased in discrete patches, as if layers were being peeled away to reveal something beneath. This raised a question no one wanted to voice publicly. Was the mass ever part of the object? Or was it something else, attached, deployed, carried? Two competing hypotheses crystallized. The mainstream explanation argued that 3I Atlas was a natural interstellar body surrounded by an enormous, loosely bound cloud of material, perhaps frozen volatiles or electrostatically trapped dust, that had dissipated rapidly due to solar interaction. In this view, the mass loss was an illusion caused by the shedding of an extended envelope. It was a conservative interpretation, favored in official briefings. The alternative hypothesis was discussed behind closed doors. What if 3I Atlas was not a solid body with a coma, but a compact core surrounded by stored mass? Mass that could be deployed, rearranged, or discarded intentionally? What if what we had been measuring was not a rock, but a system? At ESA, encrypted communications increased. At NASA, certain datasets were temporarily classified, not censored but delayed. And then came the escalation that forced the conversation into the open. At 19:06 UTC yesterday, Earth-orbiting magnetometers detected a synchronized disturbance. Less than 2 nanotesla, harmless but global. No solar flare, no geomagnetic storm. The disturbance coincided exactly with a new radio pulse from 3I Atlas. Then satellites in low Earth orbit reported brief communication dropouts. Shortwave radio operators noticed static where there should have been silence. Migratory birds in the southern hemisphere deviated from established routes, shifting westward by measurable degrees. Nothing dramatic, nothing catastrophic, just enough to suggest interaction. At 22:31 UTC, high-resolution telescopes detected a final change. 3I Atlas divided, not violently, but cleanly, into multiple components, not fragments, modules. They separated by precise distances, maintained synchronized rotation, and then, one by one, most of them vanished from all sensors. When the event concluded, only a single object remained. That object now accounts for roughly 1% of the original mass estimate. It is compact, dense, and still emitting pulses. This was no longer random, it was responding. Inside control rooms, there was a moment of stillness, a collective realization. For decades, we have searched the cosmos for signs of life, of intelligence, of technology. We assumed such signs would announce themselves loudly: radio beacons, massive structures, unmistakable signals. But what if intelligence moves quietly? What if it sheds weight, discards excess, and reveals itself only when observed closely enough? Now, in the calm after this cascade of revelations, we are left to reflect. Humanity has always defined itself by its tools, by its machines. We understand the universe through mechanisms we build ourselves. Perhaps that is why this moment feels unsettling. We may be witnessing technology that does not resemble our own, operating under principles we have not yet discovered. Maybe we're not witnessing the end of natural explanation, but the beginning of a broader one, an expansion of what we mean by object, an invitation to rethink matter, motion, and purpose. As of this moment, the remaining core of 3I Atlas continues to orbit quietly within the solar system. Its mass is stable, its pulses continue, its intent, if intent is the right word, remains unknown. The last data packet showed something unexpected, a pause in the pulse sequence, a silence lasting exactly 60 seconds, and then the sequence resumed, unchanged. So the question is no longer whether 3I Atlas is natural. The question is whether we are ready to recognize a machine when we see one. Subscribe to follow the next update, because this story isn't over.